Today's flipped lesson is going to be all about right triangle trig. So most of this you've definitely seen before. For example, first one here is SOHCAHTOA. We've all definitely seen that before and shouldn't be too difficult for us. Cofunctions are going to have to do with complementary angles, and each trig function, sine, cosine, tangent, has what is called a cofunction, and we'll talk about how they relate to complementary angles. And then finally we'll do application problems, which are going to have to do with angles of elevation and depression, and most of which you have probably seen before again. So today is going to be a lot of review from geometry, from FST, everything. So first thing, define our 6 trig functions based on the triangle that we have here. So first one, sine, remember, SOH. So that's O opposite, H hypotenuse. And remember, the opposite and adjacent change depending on what angle we're talking about. So if we're talking about this angle, this would be our opposite side. Our hypotenuse does not change, so that should be an H. Our hypotenuse does not change, always opposite the right angle. And B here would be our adjacent side. Sine being opposite over hypotenuse tells us that that is A over C then. Cosecant is the reciprocal of sine, don't forget, so we just rewrite that as C over A. Cosine then will be adjacent over our hypotenuse, so we'd use B over C. Secant again is the reciprocal of that, so C over B. Tangent then is going to be, so we've got our CAH. Tangent is our opposite over adjacent, and so we have A over B, and cotangent the reciprocal, B over A. Complementary angles then, what it means to be complementary angles is two angles whose sum is 90 degrees. So we've talked about complementary, you've talked about supplementary in the past too. For this, we only need complementary angles because we're talking about cofunctions. So cofunctions means that if two angles are complements, then the cofunctions are going to be equal of those two individual complements. The sine of one equals the cosine of the other. So for example, if we say the sine of 46, that's going to be equal to the cosine of the complement of 46, which is 44 degrees. And that's because sine and cosine are cofunctions. If we talk about secant, the cosecant, or the cofunction of secant is going to be cosecant. And so we could pick some angle here like 32 degrees, then that would be equal to the cosecant of 58 degrees. And you could do that same thing with tangent and cotangent of any two complementary angles. Big piece here is that these two angles add up to 90. Now with that said, that's how we carry on to the identities of cofunctions. So it just means, since sine and cosine are complements, the sine of theta would be equal to the cosine of 90 minus theta, which is essentially what I just did in that last slide. Cosine would go with sine, secant and cosecant go together, and then finally tangent and cotangent go together. So you're just taking one angle and subtracting it from 90, and that's going to give you the cofunction's value as well. So we kind of know 2 for 1 there on that. And then finally, our definition of angle of elevation and angle of depression. This is going to be where we have some application problems that I was talking about. So angle of elevation is going to be looking from a horizontal line up. Here we go. There we go. A horizontal. Okay. Yep. Okay. Horizontal line up. So if I can get that definition, there we go. And so what that would mean then, if I kind of draw a very rough sketch here, we'd have some horizontal line, and our line of sight will go above that horizontal line, which means our angle of elevation would be right here. An angle of depression is the same idea then, except for now our horizontal line is above, and so we're looking down with our line of sight. So it would be something more like, here's our horizontal line, and we're looking down. That would be our angle of depression. Okay, same idea for both of those. So a challenge problem here for you: if a surveyor is looking across a lake to find the measurements shown, we have this. So you want to find A, and just think about how you would apply SOHCAHTOA to that. Okay, so there's your challenge question. You can turn that in on a half sheet of paper at the beginning of class, and we will then see you next time. So big thing, remember your SOHCAHTOA. Cofunctions is just reciprocals again, or complementary angles, complementary angles, two angles add up to 90. And then finally our angle of elevation and depression for our application problems. All right, we'll see you next time.